this video, I want to give you an overview of how you can quickly build a quite effective scene for your fashion design projects. The scene we're gonna build is the one you see here in the tutorial intro. We're gonna have a quick look at how the scene is built, but the geometry is super simple. So the most substantial part of the tutorial is actually focused on how the animated shader in the background is created, as well as how the camera rig works. The way I build the scene is to add a floor plane, and then add another plane that's gonna be the wall. Scale it by 2. Create an array. Set the count to 3. The factor to 1.01. Then we apply the modifier. Mark the mesh. And separate by loose parts. So now there are 3 different meshes. If you want to see the separation of materials, you can go to the random material option. And then create an array for the first plane. Set the count to 10. Set the offset factor to 3.03. Then copy the modifier from the first plane to the second and the third one. Duplicate the array of walls. Copy one of the walls, and this is gonna be the attachment of the wall to the ground. Set offset to 1 and count to 33. Then duplicate the first wall again, scale it by a lot, and randomly place these big walls a little bit around the scene. So this is what the scene looks like. And now we can have a look at the materials. For the floor and the wall attachment, you can find a material at polyhaven.com. You can search for a concrete material and then just add it to your geometry with Node Wrangler. What is a bit more of a challenge is the animated material we have for the walls. So that is what we're gonna go through right now. The shader we're gonna create requires an image texture as input. I've used 2 image textures for this tutorial. It is the logo for this tutorial series and also this quote saying "Stay creative." And then the effect and the animation is created in Blender, inside of this shader. In this tutorial I will go through how this shader works, but I will not tell you every single value. Instead you can download this shader for free among the other free resources by following the link in the video description. I will temporarily isolate this plane just so we reduce the effect of the environment. Let's have a look at how the shader is set up. We have imported this image texture. In this case it's this one, Stay Creative. The image texture is set up with a mapping node and a texture coordinate node using UV as the input. What might be new is that the UV coordinates is mixed with a brick texture. So let's preview the image texture and see how the brick texture is impacting it. So if we change the scale with this value node, you see how the things are moving across the plane. And we also have the scale of the brick texture itself. So basically what the brick texture is doing is that it is scattering the logo to add some randomness to the animation. I have set the driver to the Y location, so let's play the animation and see what that looks like. So the driver I put into here was #frame divided by 200. And what this means is that for every frame that plays in the animation, the Y location will move 1 unit divided by 200. And a unit is 1 meter. So it's 1 meter divided by 200, which is half a centimeter. And since I'm playing 30 frames per second, 30 frames times half a centimeter is 15 centimeters. So this will move 15 centimeters per second. And you can be creative here and add the driver to multiple inputs so that the logo will move in multiple directions simultaneously. So how do we create the LED pattern that was in this material? That is also done by a brick texture. So I have added a brick texture here in a frame that I call LED pattern. And this is what it looks like. You just have to play around a little bit with the scale and the mortar size to get this look. And also both color 1 and color 2 are white and the mortar is completely black. The brick texture is combined with the animated logo effect in this frame that I call LED effect to emission. They are combined in this multiply node that creates this result. And then they are colored with another multiply node. So we blend in this yellow color, and there is another node in between those two, and I will soon go through why we have that one. The LED effect is plugged in to the emission of the principal BSDF. So this is the main emission color that we have here. To create some imperfection, we have also added some scratches and dust. And this node setup is basically a Voronoi texture. Let's zoom in so we can see it. But you see that this Voronoi texture is not a classic look, and the reason for that is that it's going through a noise texture. So we mix the mapping coordinates with a noise texture and just a tiny number here, 0.056, to distort the texture. So the original one, if we set this to 0, looks like this, and this is the classic Voronoi texture. And the more we pull up this parameter, the more we distort the texture. To make this look like scratches, we need to invert the colors, which we are doing with the color ramp. And we don't want there to be scratches everywhere, but only in certain random locations. So for that we will use a noise texture to multiply with these small dots a little bit here and there. And when we multiply that, it looks like this. So this is the look of the scratches that look quite good on a distance. Now I will go out of the isolated view and preview the mix of everything we have done so far. So it looks like this. Now when we preview the material, you can see that there are some kind of LED patterns also where there are not lit up logos. And I'm gonna show you the reason for that. So if you remember this brick pattern for the LED texture, this one was also used as a bump map. So then we create this kind of effect. And as per usual, you plug the bump map into the normal. But what I also did in this case was to plug the bump map back to the color mix. So this is a little bit different, and it's quite hard to see in this case. So what I will do is temporarily increase this factor just so you can see this effect. So we get a bit of this green and blue color into the color of the LEDs. And that is the reason why we can see them as LEDs that are turned off. Now we want to achieve a cool screen effect. And normally when you do a screen, you may want to do a pattern something like this to create these RGB colors. But this is not the effect we're after today. So let's delete this one. And we can preview the final material to compare with the one we are using right now. So this is what we want it to look like. So we can compare before and after. And what I have mixed this shader with is actually a kind of diamond shader. Now we're gonna teach you how to create that diamond shader, but we will temporarily jump over to this project where we can easier see how this effect works. Here I've created a diamond shader, and you can really see how the colors are split up like in a rainbow. This is due to dispersion, because when you're shining light through a prism, like the diamond, then the light is bent, and depending on what color the light has, it's bending in different directions. So a diamond has an IOR, index of refraction, of 2.418. But if we're gonna be careful, this value is actually for the red color, and the other colors are bending in slightly different directions. So on the other side of the spectrum, we have the blue color, which is an IOR of 2.425. So this is what we are using in our shader. So basically the diamond shader is a mix of 3 glass shaders. So we have the red glass shader with the first IOR, we have the green one with the second IOR, and a blue one with the third IOR. The red glass shader and the green glass shader are mixed together with an add shader node. And then we add a blue glass shader node with another add shader node. We are mixing this shader with a white glass shader node, which has the same IOR as the red one. And that is mixed with a mix shader. The factor to this mix shader is the transmission ray, and that is how you achieve this result. So this is the base of the diamond shader. I also added a node if you want to reduce the effect a little bit. I added another node if you want to multiply the effect and create more extreme dispersion. And I also added a roughness node. So now when you have an understanding of this shader, we can go back to our scene. So this is the exact same node setup that I used for the diamond shader, which is in this green box. And I mixed it in with a factor of 0.5. We can zoom in on this plane to see how it impacts the look. So you can already see how the blue, the green and the red are split apart. And we have a strong mirror effect thanks to the diamond shader. Look without and with the diamond shader. And if we want to increase the dispersion, we have this value here, where we can separate the colors more. So the larger number here, the more we separate the green and the blue from the red. And I even added a power node here to separate the blue and the green a bit more. But the default value here should be 1. I recommend you to download this shader so you can study the node setup in detail. And it can be downloaded for free among the free resources. But if you don't want to download it, I will also just zoom out so you can take a screenshot of the different node setups. This is the diamond one. And this is the full node setup. And then we have the LED effect, the animated image effect, the scratches and dust, and the LED pattern. So to create variations of these walls, you can duplicate the shader, add a new image texture, and then you add a driver to another parameter in the mapping node. Now you can add some lights to the scene to show off your newly designed fashion. I added both some point lights and some area lights, and I parented most of them to my avatar. Now the scene is finished, so let's just have a look at how the camera rig works. The camera is attached to a boom stand, and the boom stand is a rigged armature that allows you to get these smooth camera movements. If we have a look in the outliner, the boom stand is attached to something called a rotator. This is the rotator, and it's sliding along this rotation path. This allows us to get a smooth rotation around the character. The rotation path is parented to a root, and the root can slide along this track here by sliding this parameter. And this allows us to make movements where we are either following the character or meeting the character. As you may have noticed, the camera is always pointed towards the avatar, no matter how the rig is moving. That is because we have this camera aim here, and this aim can also be moved and animated. You may also have noticed that the avatar is sharp while the background is blurry, and that is because we have this focus object, and this focus is parented to the camera aim. So, however you move the camera, the avatar will be in focus. But you also have the option to use manual focus by going to the focus object and turn the influence to 0. Now you can move the focus along the focus path, and you can also animate it by inserting keyframes to the Y location. If you want to adjust the size of your rotation path, you can easily scale it, and the rest of the camera rig will automatically adapt without distortion. Please comment below if you want me to create a more detailed tutorial on how to build this rig. I will also upload it among the other free resources, so you find a link in the video description. Now it's up to you to be creative and combine these rig functions to create really cool camera movements. That sums up the last video of this tutorial series, and I wish you good luck with your fashion design. Don't forget to like and subscribe and share this video with your friends.
We'll be right back.